I don't know how to explain it.
So what we're going to be working with for the next while. Oh, I gotta hold on. Is it working? No, I gotta hold on. I gotta pause. Holy tabs, Batman. Let's go to this one. Yeah. So what you're going to be doing for the next couple weeks is we're going to be working with rational expressions. So this is the next unit, I guess. And I don't know if this will be broken into multiple quizzes. It probably will be. The way it usually goes in my world is when we do this at first. So rational expressions. So if I had to guess, you'll probably have three official quizzes left in this class. The first one is going to be, I'll erase this in a second after you write it down. So the first quiz would be simplifying, which is what we're doing today. And then this quiz would also contain multiplying and dividing. These are the easy ones. Again, I say that the caveat there is that you have to know how to factor. You have to be good at difference of squares, quadratic trinomials, GCF. Those are the big ones. And if you can factor, then it's pretty easy. And then multiplying and dividing is also pretty easy. Again, if you can factor, because you don't have to worry about a common denominator with times and divide. So that's what happened in like fourth and fifth grade is multiplication used to be the scary one and addition was the easy one. And then early on in like junior high, late in elementary, we flipped it because then when you add with fractions, then you have to worry about denominators. And maybe you know what I mean. It's a lot harder to add two fractions than it is to multiply them, right? So this is the easy stuff here. So today we'll be tackling just simplifying. Tomorrow we'll probably go down the multiplying and dividing road. You might even have your first quiz on this like this week because this stuff's not bad at all. Super light work, okay? So the idea here is what we want to do is we want to just simplify this. It's basically a big fancy high school version of reducing a fraction. And so what we're going to do is we're going to look at the fraction and see if we can factor. Because if we can factor, then we can cancel out common factors. The big no-no here is that you don't want to cancel things out when they're parts of addition and subtraction problems. That becomes the big thing. Um, so looking at the top, can we factor that? It's not the kind of factoring that you think of. When I say factoring, people, and this is my fault, obviously, I'm to blame. People think, oh, build your shells, do one of these. Not that doesn't always that's not always what we think of when we say factor. What do you notice about just the top? Fair enough. This is a very common kind of factoring that you've seen it before, and once I say it, you'll come back to you. But sometimes factoring is as simple as finding the greatest common factor. It doesn't necessarily mean, x plus 4 times x minus 3 or something like that. So what could I pull out of both terms on the top?
X. X.
X cubed, right? And remember, the G isn't just there for aesthetics, right? And in hindsight, I mean, someday you'll see that X squared actually would be more, when you're ready to think this way, X squared will be more efficient, perhaps. But we want to go by the book. And the G in GCF stands for greatest. So what we're going to do is we're going to take the top and we're going to pull out as much as we can, which in this case is X to the third. What's that going to leave behind? Just X for the first term and plus what for the second term? Plus 9. Good. So remember, GCF is really just reverse distribution, right? We're pulling out as much as we can. And what we're trying to do is, as it always has been with factoring, the goal with factoring has always been and will always be to turn things that are not multiplication problems into multiplication problems. I feel like I should say that 100 more times, but I'm not going to. I'm going to say it one more time. The purpose of factoring is to turn an addition or a subtraction problem like this into a multiplication problem like this. Because once you turn something into multiplication, you create something that we call factors. And factors are cancelable. Pieces of plus and minus problems are not, okay? So we pulled x cubed out of the top. We've rewritten it as a multiplication problem. And then the bottom we're going to rewrite as what it is. You cannot factor 2x squared. And it's at this point now that you're going to look for things that can reduce. We could not have, I mean, I'm not going to say can't. We should not have reduced back in its original format. But what you would spot now is that this thing, I'm going to circle it in green, contains a pair of x's, and this thing contains a pair of x's. If I were to write this out in a very raw format for you, it would look like this. The top would be x times x times x times x plus 9. And the bottom would be 2 times x times x. I don't expect you to write it out like this every time. That would be silly. But just this once, perhaps it will help you to see that there is now some stuff that I can cancel, right? Do you see that one of these x's on top can be canceled with one of these x's on bottom? And that another of these x's on top can be canceled with another x on bottom? Is there anything else that can reduce?
No.
There is not. So the final answer to this, like what I would type into my computer or what I would write on a test, my final answer would be x times x plus 9 over 2. And a question that you may not have in your mind right now, since this is our first one, is could I multiply that top back out? Like, let me click into the box here. So when you're typing in fractions in Delta Math, the best thing you can do is hit division right away. It creates a top-bottom situation then where you can just float up and down and type in whatever you want up and whatever you want down. It's a lot more efficient than trying to make it do it right later. So if I typed in this, x times x plus 9 over 2, I don't want to hit submit answer, but Delta Math would give me the green check mark. It would say, good job, right? That Pavlovian thing that we love, the green check mark on Delta Math. However, you could also multiply it back out, which you don't have to. But what would the top be if I redistributed the x through the x plus 9 over here? So I could have x squared plus 9x over 2, and it would take this just as well. What's important in this case isn't so much the format in which I write my answer. What's important is that I've exposed and canceled all common factors possible. The format then that you type it in, that's between you and the fence post, right? Okay, let's go again. I got to erase all this. Let's do a new problem. Yeah, it's kind of the same thing there. So this is a great example here. So it's a good second example for your notes. So the biggest criminal offense that you could do, and I can say this 112 times and someone will still do it. Don't let it be you. Decide right now it's going to be the person sitting next to you, not you. Do not try to cancel things like this. That is no. Anything that's part of an addition or a subtraction problem is not a cancelable entity. For things to be cancelable, they have to be what we call factors, and factors are parts of multiplication problems. The top, we all agree, is a subtraction problem. The bottom, we all agree, is a subtraction problem. Everything right now in its state is off limits. So we have to do factoring. What does the top become if we factor it down? What is this thing? What does that become? Times? No, it's a difference of 2 squares. And I know it's been a hot minute since you've done any legit factoring, but x squared minus 1, you'll remember from back in September, is just a nice classic difference of 2 squares. And what we just did is pure mathematical awesomeness. We turned a subtraction problem into a multiplication problem. Perfect. And on the bottom, we're going to think the exact same way. We're going to say, how can I turn you into a multiplication problem? This is good old classic factoring, right? What is it? Good try. I think it is the opposite, right? And had you done, I'm going to write this wrong on purpose just to make a point. Like if you had done x plus 7 times x minus 1, it's of course incumbent upon you to catch your error, right? To say that, oops, I made a 7x and a minus 1x. I didn't want to get plus 6x, right? So we definitely have to switch those signs. So let's take the two signs, the plus and the minus, and let's switch them. Let's make it a minus 7 and a plus 1. And for probably the third or fourth time already, I'll tell you, we did it. We turned everything into multiplication. So there are now four things on the board, four factors, and entities that are cancelable now because they're multiplicative factors. Do you see any from the top and the bottom that are the same? Yes, you do. There's an x plus 1 on top and an x plus 1 on the bottom, which means that we can take this one and this one and eliminate them. None of this happens until we expose them as factors. So what's my final answer going to be?
X.
Correct. And again, when you go to type these into Delta, I would just caution you, watch what happens if I type in x minus 1 and then I hit divided by. You see how it only divides the 1? So that's why it's really important that you just hit your fraction you're divided by. It's like your forward slash on your keyboard. Hit that first. And then you can just go up, down, up, down, up, and just type in whatever you want, without having to worry about all that other stuff. So in top, we're going to type in x minus 1, and the bottom, we're going to type in x minus 7. And again, you are not going to cancel these x's at the end. Why? Because they're parts of subtraction and addition problems. And anything that is a part of an addition or subtraction problem is off limits, right? That x and the other x on the bottom are not multiplicative factors. They are not cancelable entities. We agree. All right, let's see if we can find anything else unique. I had one of these on the note card, so let's go ahead and knock this one out. It's a rather anticlimactic, spoiler alert sort of situation, but still worth going over. So I think this was my fourth or fifth. My final example was one of these, but we'll do it third. So what is the top going to be when we factor it down? Attaboy. Now we're back in shape, right? Good old classic difference of two squares, x plus 9, x minus 9. And then the bottom, what kind of factoring is this? Mm-hmm. It's all I can do. What is the GCF on the bottom? Mm-hmm. And what's left?
X plus 5.
And what do you see that's the same on the top and the bottom? That's the answer I was hoping you'd arrive at. I was going to give you a few more seconds, but good. I wanted to let you know that this does happen from time to time, that you get expressions that actually can't be simplified. And so when I was playing around yesterday with this, again, I just wanted to be able to tell you that you can type it in either way. So if Landon's like, well, I already took the time to factor it, I'm going to type it in like this purple thing over here. That's fine, right? And if Dallon's like, well, heck with that, I'm just going to type it in the way it is in the problem, then Dallon could just type in what the problem says. So like x squared minus 81 over, what is that, x to the fourth times x plus 5. Yeah, because sometimes you just get a situation where there's nothing to do. Uh-oh, what did I do? What did I do?
You times X.
Oh, I did.
Yeah, you put X to the fourth instead of
Oh,
X to the third.
apologies. Anyhow, you get the idea, aside from your teacher's clumsiness with the keyboard. So sometimes the answer is just the problem, right? Let me see if I can find anything else that's unique or different. I remember thinking that there were like three or four different situations. This one, I don't know, kind of the same.
Oh.
This one, let's try this one. What's the top? What kind of factoring are we thinking on the top here? Good job. Well, good identification. So we know it's a GCF situation. What are we going to pull out? Do better. 3x. If you miss the 3, then you'll probably wind up missing this problem. Like that's not a guarantee, but something might happen that we wouldn't get a chance to see if we missed the 3. So you really want to milk it dry, like just like wringing out a washcloth. Like you want to get every drop out of it. So we have a 3x times what on top? X minus 1. You need the 1 there when you take out a whole term. When you GCF or gut an entire term, you got to have a 1 as a placeholder. And then what's the bottom going to be? Mhm. And it turns out in this case that there's absolutely nothing, right? So again, we see a situation 2 in a row where we do our due diligence, but then we realize, well, it was all for naught. There's absolutely nothing from the top and the bottom. Okay, let's find a different one. This one looks good. Let's do this one. Yeah, I like this. And we won't do too many more of these. I think you guys have the idea. And of course, you'll ask lots of questions if you're confused, right? That's what we do. On the top, what is that's a GCF, right? 6x cubed. Good answer there. So we're going to take 6 out because we know 6 and 18 can both be divided by 6. And we're also going to pull out 3 x's like this. And what's that going to leave behind?
X minus 2.
Nice. Then the bottom, it really can't be factored. Do you see anything that can go away, reduce, whatever?
Yeah.
I see quite a bit of progress that we can make. Give me something. Let's maybe do it in pieces for the sake of people that math isn't their favorite subject. So give me one thing, just simple, one simple little thing. The x's can go, right? We all agree that x to the third is a dead carbon copy of another x to the third. So this entire x cubed and this entire x cubed can go away because they're factors, right? And then what else could we reduce? And the 3, divide them both by 3, right? Which turns the 3 into a nothing, a 1. I mean, but it's pointless. What does the 6 become? A 2. So your final answer, you could type in either of these answers, is you could leave it as 2 times x minus 3. That's just fine. Or you could type it in as 2x minus 6, right? Those would both be fine because it's simplified. That's the goal here. Just simplify, simplify, simplify. Let me see if I see anything else. I don't think I'm seeing anything else unique. So you guys have the idea? Factor, right? Factor, factor, factor. Your assignment is on Delta. It should have assigned itself about 10 minutes ago. If you go there and it's not there, well, that's just Mr. Ahern being Mr. Ahern. Let me know. I think I assigned it for 8:05 or something. So let me know.
Mhm.